So having looked at strong acids and strong bases, the concentration of H plus and concentration of OH minus is quite straightforward. We find that the acid is strong or that the base is strong. We take a look at the balanced dissociation equation and we use mole ratios. Weak acids and weak bases are not quite as straightforward because of the fact that they don't completely dissociate. So what we need to do is, once we've recognized that the acid or base is weak, we still need to find the balanced dissociation equation. We also then need to look up the value of Ka or Kb. Those can be found in the same table, in fact. And then we actually need to set up the Ka or the Kb equation. Once we do that, we're able to do the calculations that we need to determine the concentration of H plus or the concentration of OH minus. So if we're dealing with acetic acid solution, 0.10 molar, I've told you Ka, but we could also look it up. Looking in the table, we see that acetic acid does have a small Ka, so it is a weak acid, so we need to dissociate it. So we have CH3, COOH, aqueous, dissociates into H plus aqueous, and CH3, COO minus, aqueous. This is an acid, so we'll set up Ka. Concentration of H plus and concentration of CH3 COO minus on top, and concentration of CH3 COOH on the bottom. Substituting in what we know for Ka, Ka is 1.8 times 10 to the minus 5. We don't know the concentration of H plus or of CH3COO minus. We do know the concentration of CH3COOH, since that's what's given. What we do know, however, is that concentration of H plus and CH3COO minus will be equal because of the 1-to-1 mole ratio in the chemical equation. So we can call those X and X. Concentration of CH3COOH is 0.10. And now it's just a matter of doing some math, calculating these out, finding the value of X, which will give us the value of H plus. So we can cross multiply. We have X times X, which is multiplied by 1, which gives us X squared. 1.8 times 10 to the minus 5 multiplied by 0.1 is 1.8 times 10 to the minus 6. In order to get X, we will have to square root both sides. And we get that X equals, if we go to sig figs, we'll need 2 of them, 0.0013 molar.